Jai Gurudev. Today I am going to discuss combination of errors and numericals. You can see already familiar what are combination of errors. See, the thing is, first there is a three things here. One is error of a sum or difference, error of a product or quotient, and third one is error may be in power raised in the quantity. So first one, error of a sum or a difference. The rule is when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. See, the rule is there, but after that I give example. If you see that, you can understand very easily. I mean, what is the statement? See, the absolute error is in the final result is sum of the absolute errors. Sum of the absolute errors in the individual quantity. So see the problem. There are three resistors are given: 50 ohm plus or minus 10%, and 100 ohm plus or minus 5%, and 200 ohm plus or minus 10%. Here you can see, first of all, resistance R equal to R1 plus R2 plus R3, so you can get 350 ohm, and then relative limiting error. That's it. Del R equal to what, so you can add 5%, am I right? And then 5%, and then 10%. So you can get what's it? Sorry, 20%. Can get what's it? 30%. Can add this one, 350 plus or minus 30%. So this is a way you can measure the combination of errors in the case of addition or subtraction. And then next, in the same way, I give another one example. Resistance R equal to V by I, where V is given and I equal to this. Find the percentage error. So here also you can add the two things. What are you getting? So percentage error is nothing but the total error in R would be given by 5% plus 2%, so 7%. The same way, another one problem. Two resistors of relative resistance R1 equal to 100 plus or minus 3, R2 200 ohm plus or minus 4 ohm. So they are asking two things. One is parallel combination and a series combination. For the case of series combination, already you are familiar. R equal to R1 plus R2, you can straight away add this one. But parallel combination is just like a multiplication format, so you can do that. R dash equal to R1 R2 by R1 plus R2. Then you can calculate what's it. First of all, R dash, and then finally you can add R dash equal to 66.7 plus or minus 1.8 ohm. Next one, error. In the case of error combination, when two quantities are multiplied or divided, the relative error in the result is sum of the relative errors. Sum of the relative errors in the multipliers. For example, you can see measure the two quantities along with the precision of respective measurements. A equal to 2.5 plus or minus 5, B equal to 0.10 plus or minus 0.01. So what's the value of AB? This is a multiplier. If you multiply the two quantities, how will you calculate the errors? So main rules of significance in multiplication and addition, like that. Significant figures in multiplication in addition. So A equal to, you know that, B equal to, so X equal to AB, 2.5 with 1.0, that is equal to 0.25. Del X by del A by X equal to del A by A plus A, del B by B. So finally you can get what? So finally 0.08. So rounding up to two significant figures, you can get 0.25 plus or minus 0.8 meter. Let's verify the option A only. The same way you can go for the next one. Two measures of A and B are given. What is the square root of AB? Very simple. Square root means just you multiply by 1 by 2. The same formula, 1 by 2 into, you can get what's that? Del X by X. The same thing, you can see that. And errors in case of measured quantity raised in power, that is equal to A square. So what you are getting? A square is nothing but the relative error is in the physical quantity raised to the power K is K times the relative error in the individual quantity. For example, you can see the problem. The relative error is del Z by Z equal to 4 times of the given Z equal to A power 4, B power 1 by 3 by C power 3 by CD power 3 by 2. So you can multiply 4 power of, what's it, 4 into del A by A plus 1 by 3 into del B by B plus del C by C. There's no power for C, and D 3 by 2. So 3 by 2 into del D by B. That's all. They didn't give any value for A, B, C, D, so you can write directly. The same way you can see the another one problem. And finally you can see that significant figures in calculations. For the significant figure, for the case of 12.0, 7.0, what is that? 1.714285. Normally you people are asking how many digits you have to maintain, how many digits you have to write, final result. So for that purpose only we need what is a significant figure. In the case of significant figure, you can see significant figure is nothing but non-zero numbers or it is called meaningful digits. See, we can see the problem. There is some rules are there. First one, in multiplication division, there are more quantities, 2 or more quantities. The number of significant digits in the answer is equal to number of significant digits in the quantity which has minimum number. For example, 12.0, there is a 3 significant figure. 7.0, 2 significant figures. So the answer should be in 2 significant figures. So minimum significant figure only have to maintain. For this purpose they are having, and the rounding off also is familiar. And the solution they are given the problem, you can see that. See, evaluate this. All the digits in the expression of our significant figure. For the case of in the numerator, first quantity 3 significant figure, second quantity 4 significant figure, denominator 3 significant figure. So the answer should be in minimum significant figure. Which one is 3 or 4? 3 only. So the answer should be in 3 significant figure. Clear. So you can write 1 0 4 0. Actually this is not a 4 significant figure, it's a 3 significant figure. Why? Because the zero last 0 is not countable. So this is 3 significant figure. In the same way you can calculate the addition, and then you can calculate the significant figures in terms of 4 3 first number 24.36, 4 significant figures. Second one, there is a 3 significant figures. Third one, 4 significant figures. So the answer should be in, that's it, 4 significant figures. So the sum is 280.7. And then you know that the unit of force 100 Newton, unit of length 10 meter, and the unit of time 100 second. So what is the unit of mass in the system of units? You know that already. Just substitute the dimension, and finally you can get what's it, m into 10 into 10 to 100 power minus 2 equal to 100. So simplify, you can get 10 power 5 kg. And next one, you know that in the base of dimension, decide the following relation: displacement of particles undergoing simple harmonic motion is not correct. So you can see one by one. So which one is simple harmonic motion rated? The answer B and C only correct definition. Which are not equal. What's the dimensions of amplitude A by T, or another one, what's it? And the dimension of y, L, and angle, that is L power minus 1, T is not dimensionless. So finally you can get B and C only the correct answer. The same way, the moment of P and area A and time T is given. Final quantity, the energy as dimension formula. So what is the dimension formula? I can substitute the formula, dimension formula, and raise the power A, B, C, and calculate the value of A 1, B equal to 1 by 2, C equal to minus 1. So finally you can get what's it? Answer D only. The same, which of the following ratios express pressure, force, area, energy, force by area or energy by volume, or energy by area or force by volume. You do everything, they apply the dimension formula, then you can see which one is equal. A and B are equal. And the volume of liquid flowing out per second of a pipe length L and radius R written by the student V equal to pi P R power 4 by 8 N L, where P is the pressure difference between the two ends of the pipe and eta is the coefficient of viscosity of the liquid, having dimensional formula ML power minus 1 T power minus 1. Check whether the relation is dimensionally correct. You can check and then you can tell it. Thank you. Next video I will come with another one concept. Thank you.